Welcome guys to another video, and this time we're working on rough planes and frictional problems. So let's jump in. So suppose we had an example and we had a static problem that involved friction. Now we know that we've dealt with smooth planes already and there was no friction applied. So suppose we had a rough plane. Now if a surface is said to be not smooth, then it is rough, hence friction is applied. Literally this means that we're going to apply frictional force and it's going to be acted in a direction opposite motion. So if we're going to push it to the right, push across, we're going to have friction pulling across it. Okay, for example, if this was the plane, and we had some kind of block here, and we're going to push it this way. This means that, and this was a rough ground, this means that we're going to be dragged out with some frictional force following it. Okay, if we're pushing it this way with P. Okay, so quite easy. What else? We know that this force is actually defined by mu r, where mu is the coefficient of friction and r is normal reaction perpendicular to plane. In other words, same principle, if there was some weight underneath, we're always going to have a normal reaction r. And if we're pushing it, wherever to the right, so it's moving this way, we're going to have some sort of frictional force here. And this F equals mu r. Okay, let's move on. Now, an example. So, let's do this, guys. So, suppose we have a mass of 8 kg on a rough horizontal plane. The mass may be modeled as a particle and the coefficient of friction between the mass and the plane 0.5. Okay, so let's try and draw this out, what we have so far. So, we have a rough horizontal plane, so not the straightest one, but this is meant to be rough. And we have some sort of mass, a block of mass, which is 8 kg down, so let's call this 8g. And we also need a normal reaction going perpendicular. Okay, now we know that the coefficient of friction between the mass and this plane here is 0.5. So straight away we can see that u equals 0.5, and now we have to find the magnitude of the maximum force P Newton, so the push which acts on this mass without causing it to move. If the force P acts at an angle 50 degrees above the horizontal, what this implies that the push here could occur like this. It could be pushed upwards, so we have no way that there's an angle 50 degrees here. Of course, using our technique, we should also consider the upwards motion. So if this was 50 and this was 90 degrees, we know here is 40. Okay, and of course, because this is getting pushed along a rough horizontal plane, we need some sort of frictional force F. Now, let us resolve. So, what do we have? So, using our normal method, resolving vertically, i.e. upwards, we have R plus, so using the cosine, P cos 40 minus, and any other vertical force, yes, down, so minus 8g. And of course, this is in equilibrium, so equals 0. Resolving horizontally, so again we look at the right side, so we got P cos 50 across, quite clear, and only 1 on the left, so negative F, and this equals 0. And of course, given that mu equals 0.5, we can also say that F, which equals this, therefore equals 0.5 times the normal reaction. So we can replace that later. Now let's rearrange this to make it clearer, yeah? So the aim is to find the value of P. Okay, so let's find this. First, we can make the first equation, replace and make R the subject. So we got R equals AG plus P cos, AG minus P cos 40. Hence, from this point, we can substitute this into this equation here, knowing that we have F. So let's put this into here. So therefore, we're going to have P cos 50 minus, so this is the second equation, F, which is 0.5 also, is minus 0.5. Replacing all of this, AG minus P cos 40 equals 0. Expanding properly, so P cos 50 minus 0.5 times AG will give us minus. So yeah, 4G plus 0.5 P cos 40 equals 0. And now all you have to do is factorize the P from here. So if you factorize, you're going to have, let's just do it, why now not? P bracket cos 50, and we take this part 0.5 and forward cos 40, so plus 0.5 cos 40, and of course plusing 4g across, we're going to have equals 4g, and hence dividing all this across, we're going to have P equals 4g over cos 50 plus 0.5 cos 40, and putting this in the calculator should give us 38.2 newtons. And that's it, guys. Hope this helps. And there's obviously an example with inclines, and you can see that in the next video. Anyways, I shall catch you soon, and good luck. Try this example again. Well, yeah, try this example again in your free time. See if you can do this without my help. Okay? Ciao, ciao, ciao.